In 2026, China will finish more mega projects in a single year than many countries attempt in decades. We're talking about the world's fastest passenger train, a dam taller than a 100-story skyscraper, entire cities built from scratch, and energy projects large enough to power entire nations.
本期节目，一个外国博主把中国2026年的超级工程和美国、欧洲放在一起对比后，抛出了一个极具争议的判断：差距可能早就不只是技术，而是谁还能把项目真正建出来。当西方还在审批、抗议、诉讼中反复拉扯，中国却在同一时间推进 CR450 高铁、海上机场、世界最高水电站以及小型模块化核反应堆。CR450 测试时速450公里，而欧洲、日本多数还停在300到320公里。这已经不是领先，而是在重新定义城市之间的距离。更夸张的是，中国直接在海上造建机场，而欧美不少机场项目却可能被拖延10几年。315米高的双江口水电站比100层楼还高，玲龙一号试图把核电建设周期压缩到约5年，甚至连能源体系，中国也不是单点突破，而是把风电、光伏、储能和超高压输电一起打包推进，让电力跨越数千公里输送。但争议同样巨大，高铁可能亏损，机场可能闲置，超级工程也可能变成沉重负担。真正的冲突在这里，当西方还在争论该不该建，中国已经在压住未来几十年的需求。这到底是无法复制的长期优势，还是一场风险巨大的国家级豪赌？接下来我们一起看看这些超级工程究竟把中国推到了什么位置。
In 2026, China will finish more mega projects in a single year than many countries attempt in decades. We're talking about the world's fastest passenger train, a dam taller than a 100-story skyscraper, entire cities built from scratch, and energy projects large enough to power entire nations. And when you step back and compare these projects to what's happening in the United States, Europe, or even the Middle East, the scale gap becomes impossible to ignore. High-speed rail lines elsewhere take decades, new airports stall for years, power projects face endless delays. Meanwhile, China is finishing them, one after another. Over the past 15 years, China has been building at a scale the modern world hasn't seen before. Not just roads and bridges, but entire systems, transport networks, energy grids, industrial hubs, and even brand new cities. By 2026, many of those long-term plans hit a critical milestone. This matters because these are not ordinary upgrades. To understand the scale, consider this. China adds more solar power in a single year than most countries have installed in their entire history. Its new rail projects move populations comparable to entire nations. And its energy projects are sized not for today's demand, but for decades ahead. So how is China able to build so much, so fast, and what are the projects completing in 2026? Let's start with the fastest train on Earth, the CR450. China already runs more high-speed rail than the rest of the world combined. By 2025, its network stretches beyond 45,000 kilometers, carrying billions of passengers every year. That alone would be enough to dominate global rail. But in 2026, China is not just expanding the network, it's changing how fast trains can realistically move people at scale. The centerpiece of that shift is the CR450 high-speed train. During test runs, this train reached 450 kilometers per hour, making it the fastest passenger train ever developed for commercial service. For comparison, most high-speed trains in Europe top out at 300 to 320 kilometers per hour. Japan's famous Shinkansen usually runs below 320 kilometers per hour. Even the fastest services in France and Spain stay in that same range. China's current trains already operate at 350 kilometers per hour on major corridors. The CR450 pushes well beyond that. So how does China go faster without breaking safety limits? The answer is not one single breakthrough. It's a long list of small controlled improvements. Engineers redesigned the train's nose to reduce air resistance at extreme speeds. They cut weight from the body structure. They improved vibration control, braking systems, and power efficiency. Even noise reduction mattered, because at 400 kilometers per hour, air pressure becomes a structural problem, not just a comfort issue. The result is a train that accelerates faster, runs smoother, and maintains stability at speeds that used to belong only to experimental rail systems. But speed alone is not the real story. What matters is where this train runs. The CR450 is designed for China's busiest long-distance corridors, routes like Shanghai to Chengdu and Beijing to major inland cities. On trips over 1,500 kilometers, the difference between 350 and 450 kilometers per hour is not minor. It cuts hours. A journey that once required an overnight sleeper train can become a same-day trip. That reshapes labor markets, business travel, and even where companies choose to locate offices. But this also raises a fair question. High-speed rail is expensive. Construction costs run into tens of billions of dollars per corridor. Some Chinese rail lines struggle to turn profits, especially in less populated regions. So why push even faster trains? Well, for China, rail is not just about ticket revenue. It's about replacing domestic air travel, cutting fuel imports, reducing emissions, and binding distant regions into a single economic system. When a train competes directly with flights on speed and convenience, airports lose demand and cities gain connectivity without expanding runways. In that context, the CR450 is not a luxury project, it's a strategic one. And while high-speed rail is transforming how China moves people across land, air travel remains essential for long distances, international trade, and coastal megacities. And by 2026, one of China's most ambitious airport projects will officially enter service. That project is Xiang'an International Airport, built for the coastal city of Xiamen. At first glance, this looks like just another airport, but the details tell a very different story. Xiang'an is designed to handle 45 million passengers per year in its first full phase, along with 750,000 tons of cargo annually. That puts it in the same league as airports like New York's JFK or London Heathrow. And this is not an upgrade to an old facility. It's a completely new airport, built largely on reclaimed land in the sea. So why build an airport offshore? That's because Xiamen's existing airport is boxed in by urban growth. Expansion there became nearly impossible without severe noise, safety, and land use conflicts. Instead of forcing growth into tight city space, China chose to start fresh. Engineers constructed massive seawalls, stabilized the seabed, and created an artificial island large enough to support multiple runways and a full terminal complex. This approach mirrors what China already did successfully with Hong Kong International Airport, but on newer engineering standards and with far higher automation. Inside the terminal, Xiang'an is built around efficiency. Passenger flows rely heavily on biometric ID checks rather than manual boarding passes. Baggage handling uses automated sorting systems. Ground operations integrate AI-based traffic scheduling to reduce delays during peak hours. These features don't just look modern, they reduce labor bottlenecks and speed up aircraft turnaround times. But the real importance of Xiang'an goes beyond convenience. Xiamen sits directly across from Taiwan. It plays a major role in cross-strait trade, manufacturing exports, and regional logistics. A high-capacity airport strengthens that role and supports China's broader coastal economic strategy. In the United States and much of Europe, entirely new major airports are rare. Most projects focus on expanding terminals at existing sites, and those expansions often face public opposition, lawsuits, and long delays. Projects like Berlin-Brandenburg Airport show how even wealthy countries can struggle to complete a single airport on schedule. China takes a different approach. When demand forecasts show long-term pressure, the response is not incremental upgrades. It's building capacity far ahead of need, then growing into it. That strategy carries risks. Airports are expensive. If traffic growth slows, underused terminals can become financial burdens. Some argue that China sometimes builds too far ahead of demand, but China's planners are betting on long-time horizons. Regional airports like Xiang'an are designed to serve for 50 years or more, not just the next decade. And transportation is only one part of the story. Because in the same year China finishes these transport projects, it also completes some of the largest energy megaprojects ever attempted. In 2026, China will switch on a structure so large it redefines what a dam can be. The Shuangjianku hydropower station, located deep in Sichuan province, will become the tallest dam ever built. At 315 meters high, it rises higher than a 100-story skyscraper. For comparison, the Hoover Dam in the United States stands at just 221 meters. Even China's own Jinping 1 Dam, standing at just 305 meters, previously the world's tallest, is shorter. But this is not about breaking records for the sake of it. Shuangjiangkou exists because of geography, energy demand, and risk management. Southwest China relies heavily on hydropower. Provinces like Sichuan generate large amounts of electricity from mountain rivers, then transmit it east to industrial centers. But recent droughts exposed a serious weakness. When rainfall dropped, factories slowed, cities rationed power, and entire supply chains felt the impact. Shuangjiangkou is designed to reduce that vulnerability. Its massive reservoir allows operators to store water during wet seasons and release it during dry periods, stabilizing electricity output year-round. Once fully operational, the dam will produce roughly 3,000 megawatts of power, enough to supply millions of homes. But building a dam this tall creates problems of its own. The site sits in a seismically active region. Earthquakes are a real concern. To address this, engineers chose a concrete-faced rockfill design, which absorbs seismic stress better than traditional concrete gravity dams. The structure flexes slightly instead of cracking under pressure. Construction itself pushed engineering limits. Workers had to excavate enormous volumes of rock, manage river diversion tunnels, and pour materials with millimeter precision. Even temperature control mattered. At this scale, internal heat from curing materials can weaken structural integrity if not managed correctly. In Europe and North America, environmental opposition, relocation costs, and limited remaining sites made large dams politically difficult. Most major rivers are already developed. China is different. It still has undeveloped river systems in mountainous regions, and it prioritizes energy security over shorter-term opposition. But while hydropower represents the old backbone of China's energy system, 2026 also marks something new. Because in the same year this dam reaches full operation, China will activate a nuclear reactor designed to change how nuclear power itself works. In 2026, China will bring Linglong 1 online, the world's first land-based small modular nuclear reactor to enter commercial operation. This reactor is located on Hainan Island, and at first glance, it looks modest compared to traditional nuclear plants. Its output is about 125 megawatts, far smaller than the 1,000 megawatt giants most people associate with nuclear power. But that smaller size is the entire point. Traditional nuclear plants take 8 to 12 years to build. Costs spiral, delays pile up. In the United States and Europe, several projects were canceled entirely after billions were already spent. Linglong 1 follows a different logic. It uses a modular design, meaning major components are manufactured in factories and assembled on site. That shortens construction time and reduces on-site complexity. From groundbreaking in 2021 to grid connection in 2026, the total timeline comes in at roughly 5 years, less than half of what large reactors usually require. So why does China care so much about smaller reactors? Well, it's because energy demand doesn't always match mega plants. Remote regions, islands, industrial parks, and smaller cities often need reliable baseload power, but don't justify building full-scale nuclear stations. Linglong 1 fits that gap. It can operate independently or in clusters, supplying electricity, heat, or even desalinated water. Safety also plays a role. Small modular reactors rely on passive safety systems, meaning they don't depend on external power or human intervention to shut down safely. If cooling systems fail, physics takes over. Heat dissipates naturally. That lowers meltdown risk and simplifies emergency planning. This design approach has attracted global interest for years, but until now, no country actually brought one into operation. The United States approved designs but has not completed construction. The United Kingdom plans similar reactors, but not before the 2030s. Russia built floating reactors, but land-based commercial modular reactors remain theoretical. China moved first, and that creates a strategic advantage. If Linglong 1 performs as expected, China gains a repeatable nuclear product it can deploy domestically and export abroad. Countries that can't afford or politically support large nuclear plants may accept smaller standardized reactors instead. From China's perspective, Linglong 1 solves a key problem. How do you add reliable, low-carbon energy without waiting a decade or betting everything on massive plants? That question matters even more when you look at China's broader energy mix. Because while nuclear provides stability and hydropower provides storage, solar and wind are growing faster than anything else. And by 2026, China's renewable build-out reaches a scale the rest of the world struggles to even measure. By the time 2026 arrives, China's energy system will cross a threshold no country has reached before. For the first time, renewable power capacity will rival, and in some regions exceed, coal as the backbone of electricity generation. And this shift is not happening through small rooftop panels or scattered wind turbines. It's happening through projects so large they look unreal on a map. One of the clearest examples sits on the Tibetan Plateau and northern desert regions. China is completing massive solar and wind energy bases designed to generate power at the scale of entire national grids. Some of these installations cover hundreds of square kilometers. One major solar base alone spans over 600 square kilometers, roughly the size of a large global city. To put that in perspective, many countries operate their entire solar sector on less land than a single Chinese project. These energy bases are not just about panels and turbines. They are fully integrated systems. Solar fields feed into high-capacity substations. Wind farms balance generation when sunlight drops. Grid-scale battery storage smooths output. And ultra-high voltage transmission lines move electricity thousands of kilometers from western deserts to eastern cities. That last part is critical. China's population and factories sit mostly along the coast. Its best renewable resources sit inland. Instead of building power plants near cities, China built the world's most extensive long-distance power transmission network. Some of these UHV lines operate at 1,100 kilovolts, a level almost no other country uses at scale. Each line can move as much electricity as several nuclear reactors combined, with relatively low losses over long distances. This approach solves a problem that slows renewable expansion elsewhere. In the United States and Europe, renewable projects often stall because grids can't move power where it's needed. Transmission approvals take years. Local opposition blocks new lines. China bypassed much of that friction by planning generation and transmission together. The pace is difficult to grasp. In a single recent year, China added over 200 gigawatts of solar capacity. That's more than the total installed solar power of most developed countries combined. Wind additions followed a similar curve. China's long-term logic is clear. It is building renewables ahead of demand, not behind it. It expects electricity use to rise as transport electrifies, data centers expand, and industry shifts away from fossil fuels. Cheap power attracts factories. Stable power attracts data centers. Clean power reduces dependence on fuel imports. And when combined with hydropower and nuclear, renewables stop being a backup option and become the main system. When you line all of this up, trains moving faster than anywhere else on Earth, dams taller than skyscrapers, and power systems spanning entire regions, 2026 stops looking like just another year. It looks like a checkpoint. Most of these projects didn't start recently. They were approved years ago, financed during earlier growth cycles, and built in parallel. 2026 is when those long timelines converge and deliver results. In much of the world, infrastructure stalls under regulation, politics, or fragmented decision-making. Projects take decades or never get built at all. China's approach trades flexibility for execution. It accepts higher upfront risk to lock in long-term capacity. Whether you see this as overreach or foresight depends on what happens next. That's the real story behind China's biggest mega projects completing in 2026. Now, I want to hear from you. Which of these projects do you think matters most long-term? And do you see this level of construction as a strength or a risk? Let us know your thoughts in the comments below.